Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, I want us to explain something to do with integration by substitution. And this is seen in Pure Mathematics 4 in page 74, whereby we are told that sometimes you can simplify an integral by changing the variable. And it is important to note that this happens when you are given an expression and you feel that integrating the variables within the expression is a bit complicated, and therefore you would wish to change the variables to make it at least simpler and then restore the variables at the end. This process is similar to using the chain rule in differentiation, and it is called integration by substitution. Don't worry, in the exam, you will often be told which substitution to use. At this level, you will be given which substitution to use. And for example, let us just look at example 6 on page 74 and find out what's happening in part A. Find the integral of x multiplied by the root of 2x plus 5 with respect to x using the substitution u is equals to 2x plus 5. Well, it is very important to note that this is what we are substituting this expression with. There is u is going to be equals to 2x plus 5. And the first thing to do is to let u appear in all aspects or in all shapes. So I would talk about du dx because u itself is in terms of x is going to be equals to 2. And that way, because at the end of the day we would wish to replace this dx, it goes without saying that du is equals to 2 dx, and therefore dx is a half du. That is what we have. And definitely, when u is 2x plus 5, it goes without saying that the root of 2x plus 5 is the root of u, which is u raised to power a half. That is, of course, known. And since we have x here in the expression, as much as we write this in terms of u, there is no way we can leave this x as x, because we cannot differentiate an expression that is having x on the other side. The next term is having u. It is not possible. So we must also make this x be written in terms of u. And we know, since u is equals to 2x plus 5, it goes without saying that x is equal to u minus 5, definitely over 2. And that is our x for u. Having reached there, now we can have the integral, substituting all the terms, and we have the integral of u minus 5 over 2. That is now the x, multiplied by u raised to power a half, and that is now this part, the root part, of course with respect to dx, whereby our dx is half du, multiplied, of course, times a half du. So it is our duty and responsibility to clean up this one, and simplifying this gives us, of course, this half times this half is going to give us a quarter, and that quarter, we are going to have the integral of a quarter into bracket u minus 5, because this 2 times this 2 is the one which gives us a quarter. So in the bracket we have u minus 5, of course, multiplied by u raised to power a half, and now we have du because this half has been used there. Moving forward, now we can simply integrate, and of course before we integrate, we can open this bracket and have multiply everything by u raised to power a half, and you're going to have the integral of a quarter into bracket u. 1 plus a half is 3 over 2 minus 5 u a half, of course with respect to u. That's where we have du. At that particular point, now we have this expression which we can easily integrate, and it gives us the integral now becomes a quarter, yes, multiplied by u raised to power 5 over 2, because this index increases by 1, over 5 over 2 minus 5 u raised to power 3 over 2 over 3 over 2, of course, plus c, of course, plus c. And our duty and our responsibility now is to rearrange these terms and find out what happens, because this is a quarter. Let's just put a quarter there, multiplied by, when we divide by 5 over 2, it's just like, when we divide by 5 over 2, it's simply like multiplication by the reciprocal, which is 2 over 5, u raised to power 5 over 2 minus 5 times the reciprocal of the divisor again, 2 over 3 times u raised to power 3 over 2, of course, plus c. At this particular point, now we can open the brackets, and before we open the brackets, we have this is 2 over 20, which is 1 over 10, which is 1 over 10, of course, u raised to power 5 over 2 over 10. This becomes u raised to power 5 over 2 divided by 10, of course, minus this is 5 over 3 times this is 5 times 2, which is 10 over 3. 10 over 3 times a quarter is 10 out of 12. 10 out of 12, that is 10 out of 12, so minus 10 out of 12, u raised to power 3 over 2 plus c. Simplifying this, it becomes u 5 over 2 over 10 minus by 2 5 u raised to power 3 over 2 over 6 plus the constant c. At that point, we need now to substitute u, because we are through with integration. We need to bring back what u was, and the final integral becomes what we say, but u was to be 2x plus 5. So substituting back u, we're going to have 2x plus 5 raised to power 5 over 2 over 10 minus 5, 2x plus 5 raised to power 3 over 2 over 6 plus the constant c. And that is the final submission as far as that question is concerned. Please note we have been able to substitute, and we have brought back the substitution at the end of the integration. So the final answer, 2x plus 5 raised to power 5 over 2 over 10 Of course, we cannot simplify this further. Minus 5, open the bracket, 2x plus 5 raised to power 3 over 2 over 6. Of course, plus a constant. And that is it. Again, visit my YouTube channel, subscribe, and let us work together. Let us prepare to understand example 6 part B in the next video. Thank you.